Hi everyone, so I'm going to go through the last three questions of the quadratics, solving quadratic equations worksheet that you were doing last lesson. Okay, so this is question 11. So solve by factorisation, and straight away, because it says factorisation and it's a quadratic, we need to put it into two brackets. So this is going to be using our product sum method. And if you can't remember how to do this, there are some videos on the last lesson, and also if you look back in our notes from the first couple of weeks in November, we've done this topic before. So the first thing to look at is what the product's going to be, and that's going to be the coefficient of x squared, so the number in front of x squared multiplied by the constant term at the end. Okay, so that means our product in this question, which are the two numbers I'm going to times together, is going to be minus 60. 3 times minus 20. Okay. The next thing we need to look at then is the sum, and the sum is the coefficient of the x term, so the number in front of the x term. So in this case, our sum, which means we're adding two numbers together, that's going to be positive 11. So we're looking for two numbers that multiply to give minus 60 and add to give positive 11. Okay, so if we go through the factors of 60, and sometimes people see these straight away and sometimes they don't, and that's fine. If you see it straight away, great. If you don't, then just have a look at factors of 60. And we're looking for a combination of numbers with some positives and negatives here because we need the product to be minus 60. So one's going to have to be plus and one's going to have to be minus because a positive times a negative is a negative. So if I just look at some combinations here, so let's say 1 and 60, they're definitely a pair of factors. Well, there's no combination here that's going to give me positive 11 with any positives or negatives here. 2 and 30, so I'm just being quite systematic here if I can't quite think of it straight away. Again, no combination here is going to give me 11. 3 and 20, still no. 4 and 15, but now I am going to get a combination that will give me positive 11 because I could get positive 15 and negative 4. So that's going to be my two numbers here, positive 15 and negative 4. So let's go back to this. So I'm looking at 3x squared plus 11x minus 20, and the positive 15 and the negative 4, we need those to make up this plus 11 in the middle. So 3x squared, positive 15x, don't forget to put the x on, sometimes people forget that, minus 4x, minus 20 equals 0. And this definitely works now because if we look here, this plus 15 minus 4, that there is definitely going to give me positive 11x, so that's definitely worked. Okay, now what would we do? We split this up and we do factors by grouping. So look at the first pair and the second pair, and we're looking for common factors. So here we've got 3x that we can take out as a common factor, and that's going to leave me with x plus 5 in the bracket, 3x squared plus 15x. And then on this side, I know straight away now from quadratics that my bracket is going to be x plus 5. And so I just need to work out what number goes in here. Well, it's definitely going to be a minus there. And then I want negative 4x, so that needs to be a negative 4. And let's just check that. Minus 4 times x is minus 4x. Minus 4 times positive 5 is minus 20. So that definitely works. And now my factorisation is almost complete, but I need it in two brackets. So one bracket is going to be x plus 5, and the other is going to be 3x minus 4. And all of that equals 0. Now at this point, all I've done here is I've factorised. This is not the end of the question, and some of you in this question, when I was looking at your work, have stopped at this point. So at that point there, that's factorised, okay? But it's not solved, okay? So solved means find the values of x. So factorised is what we've done here. I've got to keep going with this question and solve this question. So these two brackets multiplied together give me 0, means this bracket must be 0, or this bracket must be 0. And now we're just solving linear equations. So let's have a look at solving linear equations. I want to get x on its own, so let's take 5 off both sides. So that's going to give me x is negative 5. And on this side, first step, I'm going to add 4 to both sides to get the x squared on its own. So 3x is equal to 4, and then I'm going to divide by the 3 because I want to get what x is on its own. And so x is going to be 4 over 3, We can leave it like that, or if you want to, you can sort out that improper fraction, turn it into a mixed number. So that's our solution of this quadratic. And this is an example here, this number 11. It's the last one of this type. And if you're unsure on any of your other answers, you can use this as a method, pause the video and go back and correct any of your other questions. What I would like you to do though with these 3 questions is make sure you've got a correct version of this in your notes. So whether you had a go at it and got it wrong maybe, or missed a step, go back and correct it. Or if you weren't sure, if you hadn't finished it, go back and put it in your notes now, please. Okay, so that's question 11. Question 12 then is slightly different. And question 11, by the way, is very similar to the 10 that went before. So the other questions were all like this. This is sort of the hardest one, if you like, with the hardest numbers in. Okay. Question 12 then, slightly different now. And our first step, which I was quite pleased that quite a few of you did this, there's no point trying to do this with an unknown in the denominator. We can't have a variable, a letter, in the denominator. So the first thing we need to do is to sort this out. And how am I going to do that? Well, I'm going to sort that out by multiplying on the other side by x squared. So if I times by x squared on this side, it's going to get rid of that x squared. So I'm going to do the same on the other side. And that's going to give me 18 plus x squared is equal to 3x squared. Okay, I'm trying to solve the equation. So I want to get x on its own. I want to work out what x is. So I'm going to subtract this x squared from both sides to collect those terms, those x squared terms on that right-hand side. So that's going to give me 18 is 2x squared. I want to find out what x squared is eventually. So first thing to do is to divide by that 2 to get rid of that. And we've got to do that before I think of doing anything with this squared, because the 2 isn't squared, only the x is squared. So I've got to get rid of that 2 first. So 9 is equal to x squared. I'm just going to write that around the other way. X squared is equal to 9. And quite often here, people miss one of the answers. So x squared is equal to 9. Hopefully, everyone's getting x is 3 from that, because the square root of 9 is 3. But we need to be careful. We've got a quadratic here. It's definitely got x squared in it. So we're expecting 2 answers here. And the other answer is actually x equals minus 3. And let's just have a think about why that works. So what do I want? I want x squared to be 9. Well, 3 squared is 9, but minus 3 squared. So that's minus 3 times minus 3. Minus times a minus is a plus. So that's also 9. So both of these answers give x squared equals 9. There is a slightly different way of answering this, and I'm just going to go back a step here. If I went back sort of here and said, okay, my alternative method is to say x squared is equal to 9. Because it's a quadratic, I'm going to get everything on one side equals 0. So let's subtract that 9. So x squared minus 9 equals 0. And now this is a difference of 2 squared. X squared minus 9, and 9 is a perfect square. It's 3 squared. So that's a difference of 2 squares method. And if you remember a difference 2 squares method, that's going to give me x minus 3 in one bracket and x plus 3 in the other. So this is going to give me x minus 3 is 0, add in 3, x is 3, or x plus 3 is 0, subtract 3, so x is minus 3, and I definitely get my same answers as before. So that's question 12 done. I'm going to stop the video now, let you have a look at those two, and then I'll upload question 13 as well.